Alrighty folks, in this project breakdown, I'm going to show you how to construct a basic text-based tic-tac-toe game. That's going to be the objective here. I'm going to take you through really an explanation, an approach, and the code to show you how to construct a tic-tac-toe game from the ground up. This is going to be a text-based tic-tac-toe game. No graphics here, so old school console text. So do a little bit of kind of ASCII art, creating a little table for the tic-tac-toe board. And yes, we're doing it all in text Python. Absolutely. Parameters of the game it's going to be the human versus the computer. Obviously the human player, the computer is going to do its little logic to be able to come up with the next move. It's going to be the human goes, then the computer goes. And of course we will alternate. The players in this game are going to be fixed. The human will be X and the computer will be O. And I think that looks like a 0, not an O, but it don't matter because this is a test press. And so you may think, doing this text-based, how are you going to make your moves on the board? The move location is going to be determined by numerical coordinates. That's how we're going to input the moves. Obviously, because there's no graphics, you can't point and click and on a board. You're going to do move coordinates instead, and here's how it's going to work. Let's look at our basic tic-tac-toe board here. Right here. It's a great looking board, ain't it? I love it. So you got a basic tic-tac-toe board. Of course, you got your, looking at tic-tac-toe, it's X goes and O goes and X goes and O goes, blah, blah, blah. So how are we going to do this in a graphical sense? How are we going to do this in a text-based sense? How are we going to input the moves? We're going to make coordinate pairs. I'm going to redraw the board, and it's going to go like this, where we're going to enter a coordinate pairs where the first number is going to be the row of the table. The second number is going to be the column of the table. And I'm going to number them out here to give you an idea. The first row of the table is going to be row 0. So the first coordinate on the top left is going to be 0, 0. And then if you move over one column, it's going to be 0, 1, meaning row 0, column 1. And then you're going to move over again, row 0, column 2. So 0, 0, 0, 1, 0, 2. That's how we're going to do the numbering. And when you move down to row 1, it's going to be 1, 0, meaning row 1, column 0, 1, 1, row 1, column 1, 1, 2, row 2, column 2. And then you move down here, row 2, column 0, row 2, column 1, 2, 2. So now I think you get it, at least I do, where you're going to input the move with coordinates. So the game is going to be asking something like, what's your move? And you're going to enter, if you wanted to do row 1, column 2, if you wanted to place your X over here, you're going to do a 1, comma 2, because we're going to enter them in comma pairs, where comma separated for kind of user friendliness, I guess, or good look. Okay. So that's the breakdown of the explanation of the game. And now we're going to look at the approach next. All right, bitches, now we're going to discuss the approach and the strategy to this tic-tac-toe game project done in Python. And I'm going to do it in the form of breaking down each function for you. So got 5 functions in total, so let's go through them. first and foremost, of course, is the main function, of course, the launcher for any program in most languages, and yeah, Python as well. So in the tic-tac-toe game's main function, it's going to contain the main game loop, which, you know, this is going to be the thing that actually, it's going to be the engine of the game, where you're going to interact with it through this loop. It's going to go through its processes, and it'll really it'll process the moves, and then, you know, input, process, output in a loop format, and then eventually, of course, it'll end the game. It's some of its primary functions, or one of its primary functions, is going to be receiving input. I said before that the moves are going to come in coordinates, so it's going to receive the input in the form of coordinates, and it's also going to have some game control options, like the ability to print the game board at any time, of course the ability to quit the game, and some other one that I can't remember right now. And this is also going to call all the other functions, like as is typical when you're creating a game. The main game loop is going to be, well, really main generally in programming is going to be the launcher and contain calls for all the other functions. And in this case, main is going to contain calls for all of the other functions that we will discuss here. But yeah, main is kind of the home base of this program. Looking at the next one, invalid input. This is going to be kind of an error message function, where for any invalid input, this function is going to be called, and it's really going to display what your input options are. It's going to say, you know, enter two numbers separated by a comma to enter the coordinates, and it's going to detail the various commands that you can do as well to control the game. But invalid input really is going to be an error message display function. So all it's going to do is print. Moving along to the next joints. We have random CPU move. This is an important one, and this is going to control the computer's move into the game. Really, yeah, the computer's move behavior. And it's also going to employ a Python feature called a keyword argument to set the mode of how the computer does its move. I have two modes set up in this project for the computer to be able to do its thing. I have hard and easy. And it really is just the level of difficulty. That's really what it is. So the easy, the computer employs a very simplistic method of determining where to make its move. It simply chooses a random empty spot on the board, just randomly. And if the spot's already taken, it'll try again until it finds an empty spot. So very simple, you know, easy to beat. The hard mode, it employs that randomness that I just talked about, but it also is going to thwart you in your attempt to win. What I mean by that is that it's going to look for situations where you have almost won. Like if you have two in a row anywhere, either horizontally, vertically, or diagonally, it's going to put an O at that spot because you would win on the next move, so it's going to keep you from winning. So that's a little bit harder. So the harder easy. So, but overall, yeah, this is going to determine the computer's move behavior. So of course we'll go over the code, but with that keyword argument there, it's going to specify hard or easy, and I believe by default it is going to be on the hard mode, and we'll check that out when we get into the code. Next up is the print board function, and as it says, it is going to display the game board on the screen. As I was saying before in the last piece, The game board, of course, this is all text-based, no graphics, so that the game board is going to be displayed with text characters. The print board is going to it's going to display the readout of the game board and the current status at various times. Really, whenever someone makes a move, it's going to display, and it's going to display on command, where there will be a command, I believe it's called print, where it's going to print the board when you specify. Looking up next, we have the last function, and appropriately it is a determine end, where this is a function that's going to be run after each move, really, to determine if the game is over. And if the game is over, so if there's a winner, it's going to determine who the winner is. If the game is over, the game can also end when the board is full and there is no winner, of course. So if you got a board full of X's and O's but no one has won, that is the end of the game as well. So of course, the game ends two ways: if there's a winner or if the board is full. The determine end function does both of those determinations. And that is it, folks. These are the functions. This is the approach, the strategy that we're going to use to tackle this project. And next, we're going to finally get into the code. So stay tuned. Okay, getting started up here with the code. We're going to start things by looking at where everything begins, which is the main function, which is the launcher of everything, of course. First of all, getting kicked off with a couple of variables: CPU mode and mode disp for abbreviation. The CPU mode, this is going to be a Boolean variable that sets the mode, really the difficulty mode for the computer's tic-tac-toe moves, I guess you could say. So in the easy mode, it's just going to be completely random. The computer's going to choose its move. In the hard mode, it's going to thwart you from winning. Otherwise, it's going to randomly choose a board piece. The mode disp on line 95, this is it's a dictionary, really, that it's going to map the CPU difficulty mode to an actual word. You see true, hard, false, easy. It kind of illustrates that, it kind of tells you that, hard is for true and false for easy. This is used for the display of the mode, because there's going to be a mode command later on where it's going to use this dictionary to display the mode. Moving on down here to the main game loop, we have a while true, which is just going to keep looping potentially forever, but as we know, nothing is forever, right? So we're gonna loop, and it is in this loop where everything happens in the game. And as you see the enthusiastic comment here, we have the game loop. And kicking it off right on line 98, we have an input that says enter move coordinates separated by commas. So the format that the move is going to be entered in is going to be like number, comma, number. That's going to be you, the human, entering your move on the board. And of course, this move would put us up here. Row 0, column 0. Up there on the top left. So with this input, you can enter coordinates, but there's also going to be the ability to enter some words to change or to exercise some options at this prompt. And those are going to be handled with the if in the ellipse. You see here, if move equals quit or move equals Q, print game over, goodbye, and then you break out of the loop. This is going to be the situation where you're gonna, of course, quit the game. So right at this prompt, you have the ability to quit. So you can either enter coordinates, you can enter quit, and I'll get into the other options. The first elif has an option for print. This allows you to print the board. This is the display. It's going to display the current status of the board. And once it displays that current status, it's going to continue, which means it's going to, of course, go to the next iteration of the loop. The next elif down here on line 105, this mode, this is going to handle the CPU or the computer's difficulty mode. And getting in here, on the first line, we have it's going to toggle the Boolean variable, where when you make a Boolean variable equal to not itself, it is just going to change it to the other value. So if it was true, it makes it false. If it was false, it makes it true. So if CPU mode comes in here as true, then not is going to make it false. It really just toggles it back. So mode is really going to be an option that you can just toggle the mode from easy to hard. You can actually do this move to move, which is kind of interesting. You don't set the mode for the entire game, you can actually just do it move to move. So it does that changing, and then it says the computer will now play in whatever mode it's in. And see, it's using the dictionary for a display. See the dictionary up here? And see, it indexes into the dictionary using mode, which is a true-false value. And then it's going to map that true or false value to the string that tells you what mode it's in. That's how that works. And for the print and the mode options, once you do them, it's going to continue going to the next iteration. Let's move down a little bit. So once you get past the options, which are quit, print, and mode, once you get past those options, you have the code that handles the actual putting in of the coordinates and the placing of your piece on the game board. And if you remember from before, the human is always X, the computer is always O. So let's continue down here and scroll. So this try except block, I almost said try catch because I also code in Java, but the try except block is going to handle the input of the coordinates, where if I'm getting a string in the format of number, comma, number, if I'm getting that string, I'm going to split it by the comma so that I can get the individual numbers. And that's really what I do here in these three lines. I split it by comma, then I convert each element of that string to an integer so that I can really then place these items in the proper row and column using integers in the two-dimensional board array that I have not shown you yet. So I get those converted, and recall that I have this in a try block, so if the conversions fail here, it's going to go to the except. And if the conversions fail, basically, it's likely that these two things aren't numbers, or not in the right format, whatever the hell, it's going to create an exception, and a function called invalid input is going to going to run. That's really just going to tell you your input's invalid. Please make your input adhere to these specifications. And we'll look at invalid input soon. So getting down to this if, so once we've gone ahead and done the conversions for the two numbers, we're going to look the numbers up in the two-dimensional array. And if the first number is not, if it's not one of these values, 0, 1, or 2, or the second number is not 0, 1, or 2, or the length of this created list is not 2, then I'm going to call invalid input, which is also going to say your input is malformed or invalid. Please enter the right kind of input. But checking for these values 0, 1, or 2, it's just these are going to be the only valid indexes into the two-dimensional list. That is the game board. And then moving on down, once we get past the try except, it means that we have valid input. We've got two valid integers that we can then use to index into our two-dimensional list. So down to this if is going to check if there is something already in that spot on the board, on the game board. So board is the two-dimensional list that we are storing our game pieces in. And then we are going to index into the two values specified, using the two values specified. And really, this conditional is saying if there is an X or there is an O at the spot that we chose, then we're going to say no go. There's already a move made there, try again. And we're going to hit continue, which is going to loop back around for the next iteration, asking you to enter your coordinates again. So this is really the last piece of input validation, checking for, is there a game piece already at that spot on the board? If there's an X or an O, we are going to say no go and loop back around. And once we get past this if statement, we know that we can place our game piece on the board, and that is what's happening here on line 123. We're placing the piece on the board. And once we place the piece on the board, we're going to display the board, which is the print board function. And I'll show you that soon, but not yet. Moving on down to line 127. We've got if determine end. So determine end, as you can see, it is a function, and determine end is going to determine if the game is over, as I explained in the approach. And it's going to determine if the previous move was a move to end the game or not. If it does end the game, then it's going to display either who was the winner or if the board is full. And once it does that, we're going to break out of the infinite loop because the game is over. If it is not true, we're going to go down to line 129. And line 129 is we have to let the other participant in the game enter their move. So we have an input function that says press enter to proceed to the computer's move. Well, this is a dummy or an empty input where the input is not actually going to take any input. It is simply here to pause the game so that we can kind of collect our bearings and then we can see what the CPU's move is. This is a pausing technique to really prevent the computer's move from printing out immediately after your move. And you'll see it when we run the code. But if we don't have this here, you would do your move, you would see the board, and then immediately the computer would do its move and you see it, and you'd have trouble differentiating what's going on because you'd see two board printouts without explanation. Of course, you could put some in there, but blah, blah, blah. So this makes a pause so you can be ready to see the computer's move. And you just press enter to proceed. And then once you press enter, we have a function here that is going to actually do the computer's move. Random CPU move contains the logic that is going to do the computer's move. And the argument is the mode, the hard or easy difficulty mode. Once the computer does its move, you print the board again, and we put a little header on there that says after the CPU move, just for labeling purposes. And then we go to print board again, which is going to show the board. And then we do the calling of determine end again to see if the game is over. You see, you want to check if the game is over after each move is done. So somebody, either you or the computer, does a move, and then you check to see if the game is over. That's why we're calling it here. So if the game is over, of course, you end the game. But if not, we are at the end of the loop and we loop back around. So you either break or you keep going. So if the game is not over, the loop goes back to the beginning of the loop, asking once again to enter your coordinates for the next move. Yeah. And so that is main, folks, and then next we'll get into the other functions. Now I'm going to take a look at the print board and invalid input functions. But first, I'm going to show y'all how the game board is going to be represented. I was saying before that the game board is a two-dimensional list, and here it is. Basically, I've created a global variable at the very top of my code file, and just to let you know, this all these functions are going to be in a single code file. But yeah, this is declared at the very top, so it's global. Its scope is the entire file. So several of the functions will be referencing this board, so I just made it global at the top. Two-dimensional list of strings, you see, and when it's created, it's going to be an empty tic-tac-toe board, of course. And the empty portions are represented by dashes. These are minus signs. These are not underscores. So that's the board. And as moves are made, it is going to get populated with X's and O's. These dashes will get replaced with X's and O's. And I'll demo this for you in a little bit. But first, or second actually, because I've already done first, let's look at the print board function. Now this print board function, this is going to display the board at various times during the game, where after each move, it will display the board, the current status of the board, and on command, when you type in the print command at the prompt, it's going to do the print board function. So looking in here, I have a loop that's going to loop 3 times because there's 3 rows, and I have it hard coded in here because it's only going to be 3. We can leave it at 3. It's all good. So for each iteration, it's going to tab over 1 tab. This is really just to get it away from the left margin so that when you print the board, it's going to be each row is going to be tabbed over. And then the next line, what I do is I take each row of the board and join it into a string and separate it by space. So then you have, for the empty row, you have dash, space, dash, space, dash. So it spaces it out and joins it together as a string so that it basically is represented like that. And that is the print board function. And I've got the rest of my code commented out. I'm going to run the print board function just so you can see what happens when it does its thing. Simple demo here. That's what it looks like. You see, it's tabbed over, and then you have spaces in between the dashes. Another little demo here is I'm going to do a little bit of manual population so you can see, so you can get an idea of what the X's and O's will look like when they're on the board. I'm going to do some automated population here. I'm going to index into the board, and what I'm going to do is I'm going to place X's at all the diagonals. Or, well, that's not a correct statement. I'm placing X's from the top left to the bottom right, that diagonal, one diagonal. Let's take a gander at this one. See, folks, that is what it's going to look like when there are pieces on the board. Of course, in a real game, it's going to be X's and O's, but this gives you a look at some pieces on the actual board. Let's take a look at the invalid input function up here. So the invalid input function, this is always going to run based on invalid input, basically an error message or a usage message if you're coming from Linux or Unix, something like that. So in response to either the exception in that try except block where the input was invalid, or if you just enter something that's not acceptable, invalid input is going to run. And as you see, it's what it says. Invalid input, inner coordinate separated by commas. Coordinate values must be between 0 and 2. And then it details the commands a little bit. Print, mode, Q, and quit. It tells you you can enter those to do other stuff. I'll run that one real quick, or maybe really slow. There's a sample of what it looks like, but I think you could probably gather that from reading the code. So there's your little error message that'll print out. Okay, there's these two. And next we'll look at some more functions. We will now discuss the determine end function. And this is a function that's going to run after each move in the game. And it's going to determine if the game is over after the previous move. It's going to determine if there's a winner or if the board is full. So it must run after each move. You move, this runs. The computer moves, this runs. I move, you move, just like that. I wanted to get that in there. Okay. Or when I move, you move, just like that. That's the song, right? Anyway, determine end. Getting in here, looking at line 22. Well, I'm going to continue with overview a little bit here. An overview. So like, this is going to check for a winner, and it's going to check in tic-tac-toe. You can win horizontally, you can win vertically, and you can win diagonally. So it's got to check for a winner on all those fronts. So it's going to check for a winner on all those fronts, and then it is going to check and see if the board is full. And if any of those conditions are true, then it's going to say either there's a winner or the board is full, and it's going to, essentially it's going to end the game. It's going to return. And this function returns, it'll return true or false depending on if the game is over. If the game's over, it's going to return a true. If it's not over, it's going to return a false. So now we can dig in here to the code. Looking at the first for loop here, you see it's commented as horizontals, and that is exactly what it's going to do, folks. It's going to loop all the rows. Of course, there's 3 rows. It'll loop all the rows, and it is going to check for a horizontal winner. So going back to the board here, it's going to, let's look at this graphically. Let's say we got 3 X's across the top. The algorithm is really, it's going to check for the first 2 being equal, and then it's going to check for the next 2 being equal. And if those 2 sets are equal, you got a set of 3 that is equal, 3 in a row. And then if you got 3 in a row that are equal, you need to ensure that these 3 are either X's or O's, because there's another possibility. Recall that an empty spot on the board is denoted by a dash. So if there's dashes in these spots, you got 3 dashes in a row, you don't have a winner, that's an empty row. So you got to check for 3 in a row and that they are X and O. It's a good rhyme right there. I'm freestyling, right? It got to be 3 in a row, and it got to be X or O. I should put a banner up or something like that. Anyway, so I think I say anyway a lot. Looking at line 23 is where our if statement is that does the matching, I guess you could say, where I'm going to index into the board. X is the row. Notice that we're, of course, looping X. X is the row. And it's if the first element of the row is equal to the next element of the row, the element next to it, like these 2, if they are equal, and if that second element is equal to the element next to it, which would be these 2 over here, then you've got a full matched row of all the same game piece, X or O. So this is all is saying if you got 3 in a row, that's what this is. If you got 3 in a row, then you move on to the next comparison. And the next comparison over there is saying, get rid of this joint. The next comparison is saying, this is checking for the X or the O in the row. So it just arbitrarily picks one element. If that element is an X or the element's an O, it means they're all X's or O's because they're all the same. So this fully determines a full row and not a row of dashes, which would be an empty row. And that's how you check for horizontal winners. So then you move down here to the verticals, and this is going to do the same thing but vertically. So if we set this up, and let's say we got O's vertically. Look at the indexing right here. Notice that our variable here is in the second bracket as opposed to the first. That's because we are looping through the columns here with this while loop instead of the rows. So the column is the variable and the row is fixed, 0, 1, and 2. What this code is going to do is look vertically. It's going to compare the top two, see if they're equal. And it's going to compare, I guess you could say, the bottom two, and if they're equal. And if they're equal, we got to match a full column. And then we move on to verifying that they are X or O and not a dash, which would be an empty joint, as you could say. And then at the end of the situation, you check if they're X or O, like I was saying. There's your vertical. Then we can move on to looking at the diagonals. I actually like to get rid of all this stuff. I'll just redraw here. With the diagonals, I've hard coded because there's only 2 diagonals. So it's all good. It's going to check this diagonal and this diagonal. And like I said, hard coded, so row 0, 0, 1, 1, and 2, 2. That would be top left to bottom right. Checks for them all in a row. And at the end, it's checking, are they X's or are they O's? If they are, then winner. I didn't say this before, but once you determine a winner, you're going to print that they won, whatever piece it is, wins, and then you're going to return true. Notice that you have return trues for all the winners. And these are the 2 diagonals, these 2 ifs. The second one is going to check from the bottom left to the top right, starting at the bottom for some reason, but it doesn't really matter where you start. It gets the right pieces going up. And it's similar where it checks in the diagonal and then verifies that it's an X or an O, and then you get a big fat winner. So those are all the winning ones. Now we move on to checking if the board is full, which is going to be I messed that up. It's lines 38 to 43. This area. It's going to loop the rows of the game board. And it's going to check for a dash in a row. If you have a dash in a row, it means you have an empty spot. And if you have an empty spot, the board is not full, so you break. If you get all the way through this loop and you don't encounter a dash, it means every row is full, and then the else is executed. This is a for else loop, a construct that I believe that's unique to Python, where if you have a for loop and you don't break out of it, the else is executed. So the else is executed if we didn't break, and if we didn't break, the board is full. No winner, tie game, game over. You still return true because you return true if the game is over. And then at the bottom of our function, we have a return false, which is going to be the catch-all that If none of these are true, it's going to drop to the false. I'm going to return false, indicating to the calling function, which is main, that the game is still going. It ain't over yet. More to do. But that is it for this function. This is the determine end. Going to determine if the game is over. This is the moment we've all been waiting for. Now we can actually look at the completed program in execution. The pastry is coming out of the oven. Exciting times. You've seen it in bits and pieces. Now you're going to see it as a complete thing. So I'm going to hit run here in PyCharm and let's do it. So when it runs, you got the prompt, enter move coordinate separated by commas. I've talked about this a few times. In this text-based game, you're going to enter the coordinates row and column wise on the board, separated by columns, or separated by commas, not columns. It is separated by columns, but the move is going to be separated by commas. So, and I'll draw this out for you very simply. Looking at a Tic Tac board, of course, I've gone over this before. You've got your coordinates. I'm gonna start by going right in the center, and it'll be 1, 1, row 1, column 1. So let's do that. And then when I hit enter, it's gonna show me my X on the board. And there you go. Got your X in the middle of the board as advertised. Now I've got this, this message right here. Press enter to proceed with the computer's move. This is what I was telling you about before, where I'm inserting a pause so that it's not just your move and then the computer's move in a flurry where you don't have time to really process yours and theirs together. I put in a pause with the input function so that you can look at your move, process it mentally, and then decide when to see the computer's move. So it's just going to sit there and wait for you to press enter. So I do. And we see the computer has moved next to me adjacent, where it's that's going to be 1, 2. So the game is moving along swimmingly at this point. So I'll enter another move. I'll go top left 0, 0. And I got my X up there. Now I'm actually on an imminent win path. As you see, X top left, X middle. I've got one more for the win. Now, this game by default is in hard mode, so the computer is going to be, it should be, where its next move is going to be to thwart my win on the next move. So let's see if that actually happens. When I press enter to proceed, the computer should actually be moving right there at that bottom right spot. So let's see. Drum roll, please. And yes, the computer moves there. So now my move is, or my win, is not going to happen. And actually, as you see, the computer has an imminent win going vertical there. So I'm going to move there. That's the logical move because I can block their win on the next move. I don't have logic in there for the computer to sense their imminent win. Maybe I'll do that some other time. But anyway, I'm going to make my move, and that is, this is 0, 2 up here. So I'll put 0, 2. And now I'm top right. So, and I've actually got an imminent win now going top right to bottom left, as you see down here. So yeah, the computer's move is next. So the computer should move in that bottom left spot. Let's see. And it does not, because I had two imminent win possibilities where the top row was a possible win and then the diagonal was a possible win. You saw in the code that, and actually I could show it here, the check for the horizontal imminent win is before the diagonal check. So that's why the computer moved on the horizontal and not the diagonal. So if you look here in the random CPU move function, you see the check for the horizontal is on line 53. The check for the diagonals begins on line 68. So the horizontal comes first, and that's why the computer moved there first. So I still got my imminent win, so I'm going to go ahead and take it as per normal strategy. So this is 0, no, it's 2, 0. So I'm moving there, and it should be a winner. And it is. X wins, game over. So there's a run of the game. Now I'm going to rerun the game and show you the modes, how they work. Or not the modes, the commands, how they work. Mode is one of the commands. So first of all, just demonstrate the quit. You can quit at any time. If you type in quit or Q, the game's over, of course, as you saw in the code. Run it again. Printing the board. I'll make a move first. And you see the boards there, then I'll hit enter for the computer's move. Computer moves there, and then I will, here I'm gonna do a print. This will print the game board at any point. So I print it, and you see the game board again. So it is, the print is gonna print the game board on demand. How about if I enter something invalid? Enter some junk right there at the command prompt, so to speak. And then I press enter. We get my invalid input message where this is the invalid input function doing its work. Just wanted to show you that. If you enter some weird input or you enter something that cannot be processed, you're going to get the invalid input there. So there's that. And then the other piece is changing the computer's mode. And you do that, I think it's mode. I'm actually forgetting my own code. So you hit mode, let's do that. Yeah, it tells you computer play is now in easy mode. Type mode again, it's in hard. So it toggles that Boolean, easy to hard, actually hard to easy because it starts on hard mode. So you can actually change this move by move. Of course, there isn't much of a difference between hard mode and easy mode, so not that big of a deal to do, but if you want to, you can. And I think those are all the options. Let me check here real quick. Yeah, quit, print, mode, those are all the commands other than your normal game play. Let's print the board again. And I'm just gonna play through the rest of this one. And then release you to your own devices. Recess time, right? All right, let's go bottom left. 2, 0. Got my imminent win on the left side. Let's see what the computer does. And it goes there to block me, as per usual. I'm gonna block the computer in the middle. 1, 1. Blocked. And then I've got an imminent win coming down the diagonal. You see there. Enter again, should block it. Computer does block it, so that hard logic is working. And then I'll go bottom row where it's 2, 1. There's me on the bottom row. Imminent win, actually in, yeah, 2 places, so I'm guaranteed a win, I think, on the next move. Computer's gonna move 1 way. And then I can go the diagonal, and let's see, that's 02. And there's a win. So the only thing that we didn't see so far is the board being full, but I assure you it works. You can try it on your own. And that's how this thing works.